Welcome to Concept Based. I'm John Hepworth, and this one's for the Year 11 Extension students starting out this year. Now there's two situations you might be in as a Year 11 Extension student. You might be having your Maths Advanced and your Maths Extension lessons one after the other. So you do all of it, some an advanced topic first and then an extension topic. Or you might be doing them at the same time. So you're doing some advanced in the morning or on Monday and then some extension the next day or in the afternoon. So this essentially is to help for those students who are doing it separately because you will have started your extension stuff this week. So this is probably topic one in your extension, in the extension scope and sequence. This is inequalities. It's typically where it always starts because it's very algebraic based and it's coming out of a bunch of algebra that you're doing in advanced as well. Also, you've already touched on some of this stuff back in year 10, so it's easy for us to access this initially. So let's have a look at what's going on here. In the further work with functions for extension students, in the inequalities sections, there's a few different dot points. You can come across a few different inequalities, but the first one that you're going to come across is cubics that are expressed as linear factors. So hence why this is the question that I've got up here. Solve this cubic when it's expressed as linear factors. Now again, the whole point of my videos is to try and link together as many concepts as we can and to not just go ahead and solve this algebraically. We could solve it algebraically. We could just go and consider the null factor theorem and go and find where those zeros are, and then we could just go and test points between those zeros and see whether those points are below zero or above zero, and we would come to a conclusion of where the region is or the domain is of x that we are looking for a solution for this inequality. And now, sure, that way is fast. It makes it's true understanding of that algebraic process, but what does it lack? It lacks any sort of error checking ability of when you're solving these. It lacks a conceptual understanding of what this cubic is doing in terms of its relationship to being less than zero. It doesn't practice your graphing skills for cubics, which you need to do in other areas. So I would always recommend that if we can get more than one concept into our solution, then it's going to give us more of a chance to, first of all, pick ourselves up if we make an error. Secondly, be more prepared for a follow-up question if there's a part B to this question. And third, when we're doing these and we're not actually in an exam, then we're just training ourselves in a range of areas of our mathematics, not just the single one that we're doing in that class, that we're doing as this homework task, that we're doing as this specific question. So what am I talking about when delving into a range of concepts in a question like this, which is purely algebraic? Well, in year 10, you did a topic, hopefully you did a topic, in your path learning called polynomials. If you did, by the way, come out of year 10 core and you didn't do these other topics, then I would highly recommend you get your hands on a year 10 textbook that has some path topics in it and run through those. But hopefully you've seen some polynomials, and you've seen in that polynomials topic in year 10 path, you graphed some cubics. So you would have had some cubics which would have been expressed as factors, such as this one is, and you would be able to therefore go ahead and graph it. So we're going to rely on that conceptual understanding that you have of being able to graph cubics to help us in solving this inequality. Now, I have actually included a tiny little twist in this question. And the reason that I've included that is this twist actually appeared in the HSC last year. So I just want to always give kids a heads up that, hey, there's something that can happen in here that might throw you a little bit, so just always be aware of exactly what is going on. So let's go ahead and solve this using concepts, not just a straight algebraic solution. To solve this doing concepts, I'm going to do what I always tell my students to do: draw something first. So we just want to draw a sketch of a cubic. So to draw the sketch of the cubic, we need to take into consideration where the roots are, if it has them. And in this case, they're all linear factors. So each linear factor will have a zero. So we do have 3 roots for this cubic. So we know it's crossing the x-axis 3 times. And then we need to consider, what sort of cubic is it? Is it a happy positive cubic or not? Now this one has that little twist in that part of the question, because look at this linear factor right here. That linear factor is not x minus 2, it's 2 minus x. And so consequently, if we were to expand out all of these factors, which you should never do, don't ever do that. The only time we would ever have to do that is if we wanted to differentiate this cubic. So we are definitely not doing that. We are not up to calculus yet, but that's coming. So we're not going to expand anything, but we are just going to consider what the first term would be if we did expand it. Now, hopefully when you're thinking of that, you don't just think, oh, well, that would just be x times 2. Okay, that's not going to be the leading term in the polynomial when we do this expansion. It's going to be x times negative x. So that's going to give us that leading term of negative x cubed, which is super important because we understand that when we're graphing our cubics, we would be graphing a negative cubic and not a positive cubic. So this one is a negative cubic. So if we were to go ahead and do a rough sketch of this, I might just quickly check where the zeros are for this graphing it. So in this first linear function, the 0 is at 2, this one's at negative 1, and this one's at 3. So I've got two positive roots and one negative root, and I know that the cubic is negative. So when the cubic is negative, it ends up going down. Now, seeing as we're talking about concept-based tutoring here, I just want to address that as well. Why does a negative cubic go down? Like, do you understand why that is? Not just, hey, because my teacher in year 10 told me that negative cubics go down. So if you were to go and put a large value into these linear functions, and then you were to put it through the polynomial, the leading term is going to be the biggest term. So say we were out at x equals 100. This is going to be 100 cubed, which is 1,000,000, right? So it ends up being negative 1,000,000. It's really driving the polynomial down far more than the x squared or the x term or the constant would be, because it's so big, it's being cubed, it has more weight in terms of what's being done. So therefore, it's going to drive the values down and go down into this negative area down here. Maybe you knew that already, so let's get back to what we were doing. So once we've got this negative cubic that's going down to the right here, we now know, or we could now draw just a rough sketch of what the cubic looks like. I don't even consider what the y-intercept is, which you could find obviously by multiplying out the constant terms, but we don't need it. We don't care for this particular question. So we've got ourselves concepts now that we can rely upon to help us when we're solving this inequality, because we have a graph. We've drawn something. Mr. Hepworth's happy, we've drawn something. So now we want to consider what this solution is asking us. It's asking us to say, hey, when does this function less than 0? Now when you graph something, the y values are the function values. So less than 0 is below the x-axis. That's what's less than 0. So we care about parts of this function that are less than 0. So let's go and highlight some of those sections. This section between here and here is below the x-axis. See, it's got this bit down here. And then over here, this goes down below the x-axis as well. So we've got this section here to consider. So without doing any algebra, without chucking any numbers into anything, we do know which domains parts we're talking about for x that are going to be the solutions of this inequality. So we're going to use that to go ahead and write our solution. So based on the fact that we are between those sections, we can go ahead now and say that x is going to be in the domain where, now this next bit is notation. You have to be very cautious that you do the right notation. I could either do this or I could do this. The question is which one. So the curved bracket means not equal to. Now back up in here, I don't have an equals sign. I don't have a less than or equals to sign. I just have a less than sign. So the equals to 0, the right on the x-axis right there, is not actually included. And so when I write my solution, I am not going to include it. So I'm not going to include -1, but I am going to include everything from -1 up to 2, but I'm not going to include 2. And then I also have another section that I need to include, which is 3, and that goes all the way up to infinity. and I get a solution for my cubic inequality that is expressed as linear factors. And I didn't at any point do algebra. What I just did was I did graphing of a cubic that I learnt in year 10 in that polynomials section. And I highly, highly recommend that you do consider this when you do your algebraic solutions, because then your chance of getting your areas or your regions wrong is much reduced. See, an error that you could come across, you could go and you work out that you need to do something between -1, -1, 2, and 3, and you go and test points. Now maybe you test the point correctly and you know that between -1 and 2 it's negative, right? You get some negative answer out when you sub it into the inequality. But then you go and test between 2 and 3 and you make a numerical error and it goes negative again. What would you even do in that situation if that's what you've come across algebraically? Would you go and re-enter the values that you've checked in again? What if they both come out negative again because you just make the same mistake twice because you're not thinking and you're rushing now because something's happening that you're not expecting? You just wouldn't know. And that's when you're just relying on a skill and a procedure. And I don't want you just to rely on one skill or one procedure. I want you to have some sort of fact-checking system in place. From this graph, we can tell that that is an error that's been made. We should not have a negative value in that section and it should be excluded. So, if you can at any point, at any time, sketch something, draw something when you're doing algebraic solutions, so it will help you have a deeper understanding of whether or not your solution, in this case this one, is correct. If you want any help with questions done in this sort of style or this type of tutoring, then please send me a message at info@conceptbase.com.au and I'd love to help you out.